In software engineering, we are taking software maintenance. That is, to keep up the software. How to do better maintenance? Software maintenance, this is the last phase in the software development life cycle. But it is the most important phase. So how do we do it? We need to know the program first. Either it is a software or a system, the understanding is the key. Then we can do the re-engineering. The reverse engineering and the forward engineering, they both are combined and they are called as the re-engineering. So we have to find out in this reverse engineering the design. So we need to recover the design from the code and the specification from the design. Then the re-engineering, as I said, first going back, reverse engineering and then going forward, that is the forward engineering. So these are the steps to maintain, to do the maintenance properly if the project is complex, big, and if it costs more to actually replace the software. So it's better to maintain. There are different maintenance process models depending upon the complexity, the cost, and various other factors of a software under question. So the maintenance activities, we can divide these maintenance activities into two parts. They both are done, but one is productive, the other is non-productive. Non-productive means no work product is coming out of it. That is, this is the time a maintenance guy or a maintainer, he would like to understand, he would try to understand the design, the code, and of course the intricacy how the software was made. This is the understanding part, so it will not produce any kind of result. But the productive activities in maintenance is analysis, design and coding modification. That is, you're actually trying to learn the code, trying to come up with the design and then the requirement specifications. Reverse engineering in software. So how to do this? See, if you are in a car and if you use the reverse gear, your car goes backward. Same thing here. You are at maintenance right now. Now you are only having the source code. Now sometimes you may have the additional document or information, but you are analyzing the program code and recovering from it the design and finally the requirement specification. The reverse engineering is a very important maintenance technique. Why? Because there are certain software which are unstructured. They don't have proper documentation. Documentation is one of the work product of any kind of deliverable of software. And these software were not developed using proper software engineering principles. Not properly designed, not properly coded. So, the first we need to do the cosmetic changes. Like your face, you want to go to the party, you will put some cream and some powder like this, talcum powder, etc. So you want to improve the readability, you want to improve the structure and the understandability first of all, before you can actually try to learn the code and come up with a design of this code. And finally, the requirement specification. So we need to find out, first clear the code, then try to extract the design and then the specification. So the cosmetic changes, the first is that you have a code with you. You need to reformat the program. The formatting to be done properly, and most of the time the maintenance involves the changing of the names. It can be variable name, it can be data structure name, even it can be database name. So assign meaningful names. And then there are certain logical conditions, there are certain conditional conditions. So these all if else, do whiles, and a logical and or and not, and all these are used. You need to simplify this condition, and if at all there is replace this go to, just replace this go to. That is, you are just trying to do the cosmetic changes for the program to look beautiful, to be understandable. So you need to reformat the program, that is, the layout should be made neat. And you, as I said, you have to give meaningful names to the variables, to the data structure, to the function. Names should correspond to what the function is doing. Then there are complex, one by one, nested, looped, multiple nested conditional expressions. You need to simplify these conditional statements, and whenever possible, rather than having multiple if-elses, you can use case statement. So this is the switch case statement. If your programming language allows, use this switch case construct. So in this reverse engineering, what you want to do? You want to first extract the design. So in order to extract the design from the source code, you need to understand the code first. So there are certain automatic tools who can automate the process. It can give you from the code the data flow and the control flow diagrams from the code itself. So this is because the design would have lead to this code. So CIAO, CIA, Riggy, Bunch, Gen++, PBS, and there are so many in the market. There are some open source also, some are proprietary also. So these automatic tools can be used. Then what you have to do? You have to extract or find out the structure chart. What is the main module? What are the sub-modules? What are the library modules? So the module invocation sequence and the data interchange among the modules need to be extracted. And finally, when you have come up with the design, now you have to extract the specification. Because once you understood the code, the design has been extracted, the next important task is to find out the requirement specification, and this requirement specification will be the basis for the forward engineering. Okay, so specification is the key, and they may not be that much true to what actually for the old system might be having, but depending upon the design you have learned, these are the specification. So software maintenance process models. Maintenance activities are not unique for each and every kind of projects or softwares or system. It totally depends on what kind of, what extent of, what complexity of, what way the modification request or change request is received. So modification will be different depending upon the different kind of projects under question. It also depends on the condition of the product, how well structured it is, do we have the document or not, do we have the proper inbuilt documentation or not in the code, and various supporting documents. So we can have multiple software maintenance process models. If the required changes are very small, meager, they are quite simple, and the project is also not very complex, then we can do one thing. We can directly go to the code and change it. This is called patchworking or bug fixing. So these changes are reflected also to the relevant document wherever you have to change it. And more elaborate activities are required when the type of project change. This is about gathering the change requirement. You need to analyze the change requirement, and then what way you are going to change the code. You have to devise and define the strategies, then application of these code change strategies, finally the integration and testing, and the relevant document updation should be done. Whatever you have done need to update in the present document. So IEEE model, it is saying then once the modify request comes, you have to classify and identify the modify request, analyze the modification when it has to be done, do the designing, implement, do the testing again, and then the acceptance testing by the user, and then you deliver. So this is how this circle will go on in the maintenance activity. So first we will start by the change requirements gathering. We have to analyze the change requirement. That is how to change the code. You have to formulate these strategies. You cannot just go to the code and change it. And then see, if the original development team member is present, how to formulate strategies for code change. If the original development team member is there, it will reduce the working time, and especially when the code is very unstructured and you don't have the documentation properly. Also, if you have the old system available with you, that is the old system, now as a maintainer, a maintenance engineer, it greatly helps you because it gives you the insight of the old system, working old system. Now when you modify the system, you have the comparison. Okay, this is my modified system, this was the old system, this is what we have changed. And also, both systems are in front of you, so when you are debugging, program traces of both the system now can be compared so that you can localize the bugs and fix the bugs. So this is the, if you have earlier team and earlier system. So you need to gather the change requirements, analyze the change requirements, devise the code change strategies, and as I said, you have to implement the code change strategies application of this, and finally testing and the documentation updation. So this is the software maintenance process model number 1. There can be multiple software maintenance process models. So this model, if the software is a complex software and the complex maintenance projects are there, so we need to apply this software re-engineering. Okay, because the amount to replace or the cost to replace the software is very high. So we need to start with a reverse engineering cycle and a forward engineering cycle. Both are combined and called as re-engineering. So forward engineering plus reverse engineering is nothing but the re-engineering. And here we will use or reuse, you can say, the existing code and the documents. So if you want to run or high jump, long jump or high jump, then you take step back and then you jump. So when you take step back, that is the reverse engineering, then you jump forward, that is the forward engineering. So you are going from maintenance to the development, code to design, design to requirement analysis. So finally you are trying to find out the requirement specification. Then you combine this with the present requirements, and then you go with the SDLCs, whichever you want to follow. So this kind of software maintenance process models are preferable when amount of rework is quite significant and software has a poor structure. So the rework, if it is significant, we cannot just go and do the patchwork or fix the bug at local point. We need to reverse engineer and then find out the specification, and then only with the new specification do the proper the application of software engineering principle, that is called the forward engineering cycle. Forward engineering cycle comes only after the reverse engineering cycle. Okay, so this can be represented by a reverse engineering cycle. As I said, reverse engineering cycle always is giving rise to a forward engineering cycle. There is no separate forward engineering cycle. So this is the existing software. First you will start with the code, go to the design, then to the requirement specification, and then you will restructure. And then when you restructure, you go to the forward engineering, and then you produce the product called re-engineered software. Here also you see that code to design and design to code. First you have to start with code, go to design, that is reverse engineering. Then again from design to code, that is the forward engineering. This whole process is re-engineering. So software engineering, re-engineering, because many of the software products, they need a lot of maintenance. They are aging software. You're starting from code, you're going to design, you are going to requirement specification. Now you're adding the new requirements or the change request, and then you are going again forward from requirement specification till the testing process. That is called the forward engineering. So reverse engineering plus the forward engineering is called as the software re-engineering. So during this reverse engineering, the old code is analyzed, that is to every level of abstraction, because we need to find out or extract the module specifications. Now when you know the module, how is the cohesion coupling, how is the module being formed, what is the patterns you have used, and what are the architecture, the module specification are analyzed in order to produce the design. And then the design is analyzed, that what requirement, what use cases has finally devised this design, has created this design. And then you come to the original requirement specification. So once you have the original requirement specification, which has come from design, which has come from the old code, now you add this with the change request. Now the change request or change proposals are then combined with the requirement specification. Now you arrive at the new requirement specification. Once you are having the requirement specification, it is just like creating a new software. So now you do the forward engineering to produce a new code. And during this, during the design, modification, module specification and coding, there is a substantial reuse, because there are reverse engineered products we can use. Process models for software re-engineering. Because whenever you have a big project and big proposals to change, you start with the reverse engineering. You already have a code with you, and there can be document to support, to help you, or there may not be. So you start with the code, go to the design, and then you create the requirement specification. This is called the reverse engineering. Now you are with the requirement specification, you add it or combine it with the change requirements. Now you are having a new requirement specification. So this new requirement specification, old plus change, becomes new requirement specification. Now you can go ahead with the forward engineering to design and code. So software re-engineering, what are the advantages? First of all, whenever you are doing things in a new way, you have a better design. You are creating documents, so you have a latest document. And since the performance and the enhancement and the efficiency is always increased, because you're making the new project with new technology, new thoughts, and re-engineering is preferable when the rework is quite high. That is, you cannot go with just patch fixing or bug fixing. And when your product is showing with respect to reliability and availability, the failure rates are quite high, then re-engineering is always preferred. Though it takes a lot of effort, but it is always advisable when the product is very difficult to understand. Re-engineering is the key. And since, as I said, when you have a better design, the efficiency, the efficacy, the performance, the other quality measures, they increase. This approach is more costly than the first approach, that is the first model, which is bug fixing and patching. Empirical study says that the first process for just bug fixing and patching, this second one is only applied when you have a rework which is more than 15%. Process 1 is only applied when you have rework less than 15%. Okay, this is all about this discussion. Thank you so much. Take care of yourself.